Cool. So here we have next speaker, Ram from IBM, to talk about multi-cluster service mesh patterns.
Great.
Enjoy.
Thanks for the introduction. My name is Ram Vennam. I'm a product manager for IBM Cloud. I work on the IBM Cloud Kubernetes service, more specifically the managed Istio add-on to the top of our Kubernetes service. And today I want to talk to you about kind of what we see people doing with multi-clusters, how they're using multi-clusters, and I'll talk about how the Istio community is trying to support expanding service mesh across multiple clusters. But before I get into the how, I want to talk about why. Right? We're really in an exciting time to be in application development, deployment, and also the management of all these apps. And right now, I believe our focus is all on speed. Right? Websites are the primary interaction layer with the end users, and it's not okay for your application to go down, and you can't expect users to just try again another day. Users expect your site to be available 100% of the time, respond quickly, and also from everywhere where they're located. New features need to be developed, deployed, and then rolled out in days, not weeks or months. And for that, things like canary testing, AD deployment, and the monitoring of your new versions of it becomes really important. And also, if you want to hire good developers, I believe that you should really have a modern application stack and also a modern DevOps culture. And these requirements are really forcing every company to become an IT company, and also forcing them to adopt the latest technologies faster than we've ever seen before. I talk to a lot of clients in my role that are part of this digital transformation journey, and everyone is at a different point in the journey. We get some customers that where we just kind of explain to them what a container is and how to move from VMs to containers, and then hop on another call where customers are talking about pushing 5,000 or 10,000 events per second through the ingress gateway, and they're trying to ask us how to do pod auto scaling with the ingress gateway. Right, and that's okay. Everyone's at a different point, but the problem is that there's no kind of one path to the journey, and everyone has different requirements, and they're kind of playing around with different technologies and getting to it in their own different way. Like think of the CMC app, it's like a shopping cart, and they're using the technologies to get to where they need to go. But what we can do is learn from their different use cases, from a community point of view, learn from their different use cases and identify patterns on how they're accomplishing this. Right. So, for example, as a community, we determined that packaging up your microservices into containers and managing them as containers is a pattern. And then using something like Kubernetes to orchestrate those containers is the next step of pattern. And I think what we're seeing is that most of our clients are at this point in the journey right now. And anything past that, service meshes and other technologies are still kind of a wild west, and we're still trying to play around and determine and learn from what other users do. Okay, so we don't just see that customers have one cluster, they have many clusters, or even tens or hundreds of clusters. And there's really many reasons for this kind of distributed nature of creating multi-clusters or using multiple clouds. And the main one that jumps out is definitely performance. We want our edge applications closest to our end users to reduce that latency time. We want our backend applications closer to our backend data or our APIs, wherever they are, again, to reduce the latency time depending on your workload. You can create a cluster per workload so that if anything bad happens and the cluster goes down, kind of the blast radius is isolated with just that one particular workload. This is the third one, dev test pro environments is probably what I've seen the most is customers are isolating their different environments, and every team and every environment gets its own cluster so they can kind of spin up and take down and use it as a consumable resource. And this also gives more control for each of the dev teams to do the various testing as they get it. Cost, well, different clusters cost different amounts, right, based on what you feed the clusters, which VMs. If you're feeding dedicated or bare metal VMs to your cluster, it's going to be more expensive than just use public shared multi-tenant VMs with your favorite cloud provider. And finally, you can set up multiple clusters just for redundancy. You have multiple clusters, they all have the same services, pods, namespaces, and you want failover. So with these kind of being the requirements of why people are adopting this distributed nature of culture, let's kind of next talk about looking at it from a microservices point of view with containers. Right? We still have the same requirements for our service mesh, even if you have a distributed application process. We want security, we want encryption when microservices are talking to microservices residing in a different cluster. We want to do canaries and A/B testing regardless of where that microservice lives. So you can leave your production cluster alone, and then you can do canary testing with just one deployment of the microservice, right? You want to be able to enforce your circuit breaking, rate limiting, and other fault tolerance policies in place from a single control plane and how to protect all of your clusters and microservices. And last but not least, definitely observability into your traffic flow and what's coming in all the way to response to our point of view. So they're jumping straight into it right now because it's a lightning talk. There are 3 patterns that are available right now in Istio for setting up this multi-cluster. And each one of them has its advantages and disadvantages. So I'll just cover all 3. Unfortunately, I wanted to do like an animation, but I didn't think I'll have time to actually go through each one of those steps. So this is the first pattern. This, I'll call it flat network single control plane pattern. So on the left is your cluster 1, which is your main cluster, or your local cluster, as some documentation calls it. And then cluster 2 is your remote. With cluster 1, you have the full Istio installed, so you have the full control plane, pilot, mixer, galley, all the other full Istio installed, Citadel, injector. And then on your remote clusters, you only need Citadel to manage security and your admission controller, sidecar injector component, right? So it's a much smaller Istio. There needs to be some configuration and credentials exchange that needs to happen. So cluster 1 needs to be able to talk to the Kube API of all your remote clusters. That's how it discovers the services that are deployed to it. So in order for that, you need to share your config credentials through cluster 1. And you can do that with secret. And the envoys on cluster 2 needs to be able to report back telemetry data, needs to be able to check the policies, and all that is back in the control plane cluster. So you need to share the IP addresses, the endpoints of each one of your control plane services to each one of the remote services as well. So there is a little bit of setup that goes into this. Okay. The biggest requirement of this setup, like I said, is that the internal network of one cluster needs to be routable from the internal network of all your other clusters. So that means like the pod IP network range and the cluster IP network range of all your clusters cannot overlap, and one pod IP needs to be able to be routable to the pod IP in a separate cluster. The second big requirement of this service, of this setup, is that you need to set up all your clusters identically when it comes to your services and your namespace and your service account. And that's needed for DNS lookup, which I'll kind of talk about when I go through this flow. Let's see if I missed anything. Okay, I think I covered the base setup. Now let's walk through the flow of how pod foo, which is in cluster 1, wants to talk to pod bar in cluster 2. So even though pod bar is in cluster 2, we need to define the service for bar on both cluster 2 and cluster 1. So now when 2 wants to talk to bar, pod foo will look up. So we will look up bar, we'll get to this service, and Kubernetes will reply back to the cluster IP, the virtual IP address. And because Pilot knows about the services that are deployed in all the remote clusters, it knows that bar is deployed in cluster 2, and it knows the pod IP in cluster 2. So it can configure Envoy to replace that or to forward that cluster IP that it found directly to that pod IP that's residing in cluster 2. So now it's able to use that pod IP and just make that connection penetrate. So some caveats to this model. Because of that config exchange that needs to happen, both sides need to know each other. If anything happens, like if one of these Istio system services needs to restart and they get a new IP address or something, then you do need to go back and update the DNS of all the remote clusters to make that happen. The same thing with anything with two config changes, you do need to do that. But you can use tooling, any type of pipelines that you're using to deploy your applications to maintain this consistency with not only the Istio configuration, but also maintaining those namespaces, pods, and services consistent across all the components. This type of setup is pretty good if you have multiple identical clusters all residing pretty close to each other, and you're using some sort of CI/CD tools to make sure that they're all staying consistent. There is a lot of traffic that goes between each one, so it's good that they stay together. And of course, you have that requirement of flat network. If you don't have it natively, you could use VPNs or NATs to set this up, but you'll still need to configure Kubernetes so that there's no overlap of any of the seeded blocks. I'd say that this setup is best if you want to do like failover type of scenarios because they're all sitting next to each other. You deploy a bunch of pods. You could do canary testing as well, where you deploy a different version of the pod to one cluster, and you can still apply your virtual services and destination pools as you would to route it to just one particular pod. The next pattern, single control plane, separate network, meaning there's no flat network requirement in this approach. Again, cluster 1 is your master cluster, and cluster 2 is your remote cluster, full Istio, smaller version of it, smaller Istio. And really what's different about this one is that because there's no flat network, it's going to rely on the Istio ingress gateway to do the communication. So each one of the clusters, you treat them as separate networks. They have a network label associated to it. That network label, associate that with the ingress gateway, and all the services that are in that cluster are also associated with that ingress gateway. So walking through this flow again, Foo wants to talk to bar. Bar service is defined everywhere. Foo asks Kubernetes where bar is. Kubernetes comes back with the cluster IP. And again, pilot knows about where the pod bar is running. It knows its health, so it's able to come back and instead of now giving it the pod IP address, it will give it the IP address of the ingress gateway. A couple of interesting features here. It uses the Envoy API split horizon EDS to return back the configuration depending on who's calling it. So if someone wants to talk to a service that's residing in the same cluster, it will have the same network label, so it's just going to return back that local 10 dot address you're talking about. But for services that are in a different network label, it's going to come back not with the pod IP, but with the ingress. And this lookup happens based on which endpoint it's trying to access. And then when this communication is happening, it's going through the ingress gateway. Obviously, it's encrypted, but it's got SNI information on it, so the ingress gateway is able to read where the routing needs to happen once it receives it on that end. Okay. As far as the pros and cons about this, I think the benefits are very similar to the first setup. It's great for redundancy and failover, and you can definitely do canary testing. An advantage is that your platform administrators have this single control plane where they can enforce policies that affect all your different clusters, and that's definitely a value add if your department is set up like that. The third setup, multiple control planes. This setup is the simplest in that every cluster is running full Istio, and there's really not much setup that goes into it initially, like there's no configuration setting. And the big advantage of this is that you kind of do it on a case-by-case basis. You pick your service that you want to expose to the different cluster, and then you only need to set it up for that one particular service. So walking through the flow for this one, pod 2 of the bar. You don't have to have the service bar defined in cluster 1, but instead you define a service entry. It's treated as an external. And bar gets added. Istio uses extensions to the Kubernetes core DNS, and also provides another core DNS server inside to add the .global search prefixes to the existing list of prefixes that Kubernetes searches for, or to do your service name resolution. So for example, when foo wants to talk to bar, it'll search for bar, and then bar.service.cluster.local, and bar.service.local. And then at the end of the list, Istio is going to add bar.namespace.global. So if it's not able to find bar in any of those top, it's not able to find it on any of those top search prefixes, it's eventually going to get to .global. And Istio has configured Kubernetes to look for the address of bar.ms.global inside the service entry. So instead of cluster IP, it's just going to map to some randomly assigned virtual IP, which then Pilot uses to configure it to forward to the ingress gateway of the remote cluster where that is. And that address is not discoverable automatically, unlike step 2. You actually have to define the remote ingress gateway IP in your service entry page. And in the communication, again, I'm going to encrypt it on this side, uses SNI information, goes to the ingress gateway, and then it routes it to wherever it needs to go once it reaches the cluster. This pattern is good when you don't have clusters all sitting next to each other. Each one of your clusters is under different administrative control, a different team, and you're kind of picking and choosing based on which service you want to do. This is great for hybrid environments. Maybe I have cluster 1 in a public cloud somewhere, and cluster 2 is on an on-premise private cloud. But there are some scenarios where you want to do maybe failover or Mary testing or any type of flows where you want to route. You can pay the extra latency cost to route traffic outside of the cluster and go somewhere else through the public internet and go through. This system obviously definitely scales better than the other ones because there's less configuration, both from an operator point of view, but also to maintain. If you want to remove that connection, you just leave the service entry and each of these patterns I talked about is covered in more details. Itai wrote a blog post that went into much more detail than I could in this lightning talk. And then our goal of doing this is to learn from the community to see what people are doing with multi-clusters and which one of these patterns makes more sense for them to adopt and what they need out of it. I believe all 3 patterns are a pretty preliminary phase where we expect a lot of the features to work, but I would not say they're kind of like battle tested, and additional features such as ease of the maintenance of the configuration and the lifecycle management of these remote clusters, I think it's still left to be more of what needs to be done. So we created an associated a survey as well. It's kind of like 10 or 15 questions where we're just kind of asking you, what you're doing with multi-clusters and what you're looking to get out of Istio service mesh. If you just Google Istio multi-cluster patterns, you should be able to find one, and then from there you can get to the other one. There's also a video that goes into more detail about what I just talked about in the last few minutes. And with that, I'll say thank you and open for questions.
So when you mentioned a single control plane, that outside the Kubernetes, right? You still have your own Kubernetes, its own control, plane. Then on top of that, you have your Istio control plane, right? When you mentioned about single control plane, that's for the Istio control plane,
when I
right?
say the single control plane, I mean the Istio control plane. Yeah, the Kubernetes control plane is separate. Kubernetes is still has its own control plane for each one of the clusters.
Right,
So
and all the scheduling, let's say, which workload running on, that's still,
that's
you have
still
to,
the scheduling is still managed by Kubernetes.
you have to manage, individually, I guess, right?
Right, individually. Yeah.
Okay.
So Istio is not helping you with as far as the deployment of your systems.
Okay, thank you.
Besides Istio, is there any other model with which people are deploying the services, the microservices-based architecture?
As far as the service mesh requirements, Istio is not helping you deploy your applications. to
Like
the
writing the
clusters,
applications like that.
Can you be more specific on any type of requirement you have from multi-clusters?
No, I just wanted to know, are there other models you are seeing in your practice?
Gotcha. We definitely see users using technologies like RFA to help them deploy their applications to multiple clusters, kind of abstracting away all thought process of where the cluster is, etc., and then just using native like Kubernetes CRDs to define the requirements of the application, and then letting an external tool read that requirements and then deploy it to where it needs to go. That's another kind of thing.